Hello, good day. I would like to present to you my paper titled Machine Learning Assisted Wavelet Whittle Estimation of Gegenbauer ARMAX. I am Alex Gonzaga from University of the Philippines, Manila. So in my talk, I'm going to discuss the following: the motivation of the paper, which is the ARMAX model, and the model which we developed based on ARMAX is the GARMAX model. And we provide here the machine learning and statistical approach and estimation, which is a hybrid estimation technique for the GARMAX model and some simulation results. So the ARMAX, the classical ARMAX, or the autoregressive moving average with exogenous model, is just the ARMA model defined by these polynomials phi of b and theta of b with exogenous effect xt, which is linear in this sense. Now we extend this to what we call GARMAX by incorporating a long memory parameter d. So this is now a long memory model and a pole at lambda corresponding to u here, which represents the periodicity of the series. So this is now an extension of ARMAX model into a long memory model with periodic component. So ARMAX now is just a special case of GARMAX, and this is now a more general model. So it's GARMA with an exogenous effect given by XT. So if you look at the spectral densities of GARMA and GARMAX, we will see that both of these have poles at lambda. So GARMA has a pole at lambda, and the presence of exogenous effect doesn't affect the presence of the pole still at lambda. So that corresponds to the periodicity in the series. So it does not only detect long memory, but also the periodic component of the time series. So the spectrum of the GARMA process, in this case, in particular, the 3-GARMA model with poles at 0.1, 0.3, and 0.45. The spectrum is given by this, and we see that the poles here are at 0.1, 0.3, and also at 0.45. So these poles represent the periodic component of the series or of the signal. And the slow decay of the slow decay of the spectrum, this behavior with the spectrum represents long memory, which corresponds to slow decay in autocorrelations. So this one is an example of time series that represents a GARMA model, and it is the log square returns of Microsoft stock exchange stock prices. And you will notice here peaks at these poles at these frequencies corresponding to the poles in GARMA. So the hybrid estimation involves MLP, machine learning, perceptron, CNN, and also with the likelihood estimation. So we decompose the model this way. So the time series is now represented by yt equals g of xt theta plus rt. RT here is the GARMA, the residual component that is GARMA. And G here, this function of xt will be the machine learning regressor. So this allows for nonlinear exogenous effect. So we allow here the machine learning component here represented by gxt allows for nonlinear exogenous effect. So So that's what we model first, the nonlinear exogenous contribution, which is GXT, using the the standard neural network MLP. And the specification, this standard specification is given by this, where B2 is the bias, and the weights are W2, and sigma here is the activation function. So this allows for nonlinear estimation of the exogenous effect. Now, we obtain the residual series. The next step is to obtain the residual series given by RT, and by subtracting the GXT here, and we compute the maximal overlap discrete wavelet transform, or the mod WT, of the residual series R sub t hat. So we use here non-boundary wavelet coefficients. And to recall the maximal overlap wavelet transform, it's given by this. So for time series Z sub t, the maximal overlap discrete wavelet transform is given by W sub jt. And so this is just a convolution of the wavelet filter and the time series with no downsampling. And we only consider here non-boundary coefficients, those that are not affected by boundary conditions. So we obtain the maximal overlap DWT of the residual series RT. Now, after obtaining the residual series and the wavelet transform, we will have a scalogram like this, which is a two-dimensional image, no, which is a time scale energy map of the for the periodogram. And that's why we use here convolutional neural network to initialize the Gegenbauer frequency lambda, because in the presence of exogenous effect, the standard or the usual method of peaking from the periodogram may not be accurate. And so the use of convolutional neural network can improve the accuracy of the initial value of lambda, which could affect the estimation of lambda later on. So we initialize lambda here using CNN on the scalogram, the standardized scalogram. So we just choose the non-boundary scale energies. We discard scales with negligible energy or dominated by artifacts. Then in step 5, we now estimate the parameters of the Garma model using the Whittle likelihood in the wavelet domain. So the wavelet domain diagonal approximation is, and we consider standardized coefficients given by this. So this W sub jt represents the non-boundary wavelet maximal overlap wavelet coefficients, and we standardize this. And these standardized coefficients are now used in the Whittle likelihood given by this. And we estimate here the parameters of the Garma model, and a new value of lambda will be estimated here. So CNN only initializes the value of lambda. The Whittle estimation procedure estimates all the parameters of Garma, including including lambda, which was initialized using CNN. So here are some simulation results. So we simulated time series, GARMAX time series, this way by simulating gamma plus some exogenous variable with coefficient beta. And so this term here actually represents an AR1 process with coefficient 0.5. So we consider three different sample sizes for this. N equals 128, N equals 512, and N 1024. And the true parameters are specified here: 0.3 for D, for U 0.6, beta is 0.5, and sigma is 1. Okay. And we use the MB16 wavelet, which is of length 32. So if you look at the results, we see that the advantage of the hybrid method can be seen in the estimation um, of beta, and also the estimation of the coefficient, no? And particularly when the sample size is large, no, for the estimation of U. So in fact, for N equals 1024, the values of the parameters, the estimated values of parameters are more accurate for the hybrid method than the usual Whittle estimation without the machine learning components. So, in conclusion, the GARMAX model offers a powerful extension to various time series models, including ARMA, ARMAX, and GARMA models, by simultaneously accommodating long memory and periodic or the cyclical behavior, and also exogenous influence in the same framework. So all of those are in GARMAX. The simulation results highlight the method's competitive performance in capturing both the fractional parameter, which is the long memory parameter, and the exogenous coefficient with smaller bias than the classical Whittle approach, particularly for moderate sample size. By leveraging the redundant maximal overlap DWT and the Whittle type likelihood, this hybrid approach provides more accurate estimates of the parameters. Thank you.